Welcome to Coding Adventures. Today we're gonna discuss about sprites and see how can we use sprites to create nice and beautiful games. So let's get started. Alright, so I'm here on my desktop and I'm gonna start the code browser, the code editor inside the browser, but we'll not go straight into the coding, but instead I want to show you some games that are on this platform. So if we're browsing the tutorial section and under the games, we can see a few nice games here. Perhaps let's pick this one and run it. Alright, let me have some fun playing this game a little bit. It's a retro style shooting game. And the main point with this game is that all this is implemented in JavaScript. And right now we are far advanced into the course that we are about to start, and we can create this kind of games on the CodeGappy platform. And this is the topic of the today lesson, so let not me waste some other time. Let me stop the game and let's see today what makes that game tick. Alright, and what makes that game tick mostly are the sprites and animated sprites, for instance. So let's go into the code editor and let's do a little bit of recap about the sprites, because we encountered sprites until now in lesson 3, I guess. And back then we went into the browser palette here, we explored the palette of sprites and we used to drag and drop a sprite into the editor. So let's do the same exercise one more time and remember how to use sprites, and then basically we'll go a little bit deeper this time. Alright, so let's pick a sprite. Perhaps let's pick this plane this time and we'll drag and drop it in the code. And if we are inspecting the code really closely here, we can see that a line has been added into the editor for us. And it's a single kind of function invocation. It says sprite, and then this one takes some parameters, basically the sprite that we want to display in a format sprite dot, and this is the current animation. We saw that some sprites have multiple animations inside, and then these are the coordinates where we want to display the sprite and basically the size of the sprite. So let's run it. And indeed we have a cute plane here on the screen. It's animated, you can see the propeller going, and that requires just one single line of code, right? And we can even beautify this more. Perhaps we can put this background behind the plane to make it a little bit more realistic. Let's put the background first, although it doesn't matter. And if we run it again, we can see that the plane now is running, perhaps at a little bit higher in the sky. Alright, so this is a nice, cute sprite, a simple exercise. We just drag and drop one sprite and one background in the code, and we got this beautiful imagery. Now, the main question, since we are here talking about coding, is how can we manipulate this sprite using code? How can we access this sprite and make it move on the screen, make it go to the right, to the left, up and down, similar to how we basically can draw things on the screen in any position. And sprites are a little bit different than the regular kind of drawing. And let's remember that in this environment, basically there is there are a series of layers, one on top of the other. Let me show you that one. Like here, we have the background layer on top. Then we have sprites, the drawing layer. The drawing layer is basically where we used to draw until now all those shapes such as circle, ellipses, and so on. Then we have another layer of sprites, and then finally a layer with some HTML widgets. Nevertheless, see, the sprites are not inside the drawing layer. So therefore we can manipulate this independently, right? So if we move a sprite on the screen, it will not overwrite whatever drawing we have there in that layer. So this will create some interesting possibilities. But let's stop talking and actually let's see how we can move this plane, shall we? Let's put it a little bit higher. It's too low. All right. So and perhaps starts here, not at 400, but starts a little left of the screen. Now, see, initially when we position the plane, obviously we can put these parameters here and we decide where we want to have it on the screen. But now we cannot go like in case of circles, and this, if we want to have the plane in another place, just invoke this sprite command again and put another number here. With sprites it's a little bit different, because sprites, once they basically place that plane on the screen, they are some sort of a living object inside the memory. So instead of just draw another sprite, we can use this living object and manipulate it, right? And basically this function, the sprite invocation, actually is returning a reference to the actual sprite, this object that is in the memory. Let's name this P from plane perhaps, right? So if we invoke this, if we run this code again, nothing will happen. We're just taking a reference to the current sprite in a variable P. And now this variable is special. It's an actual object, and it's similar to the objects that we studied yesterday. So it has properties, it has other members that we'll call methods. But let's try a property first. One of the properties of this object, and since it's an object, we access it via the dot notation, is the x and x coordinate or x property, and we have another one similar for the y. Right, so we have this plane right now at 100, 100 and 150, and let's see if we are changing this one and make it at 400, and if we run it, actually we see that the plane comes back in the middle of the screen. If we don't change this property, well, the plane starts, it's exactly where we started it, right? And we also said that we have one property for the y that basically controls the position on vertical. So as you can see, the plane jumps here. Now changing the properties in the code and rerunning the code is not fun, so therefore perhaps we should just try to make this plane just move by itself, shall we, in a loop function. That's what we want to do. Remember about the animations, we have a special function named loop here on the platform, and the browser will just invoke it up to 60 times per second. So therefore we don't have to call it. The browser calls it for us. All right, so what we can do inside here, we can basically, let's just increment the x position of the plane. What do you think will happen? Let's see. And the plane is flying slowly, but is flying across the entire canvas, is reaching the other side, and is going. Bye-bye, plane. Obviously, the code is running and is running fine, and look at the simplicity of the code. This is, we just set some properties and the plane is running, right? And this is very powerful because these sprites, as a side note here, are powered by a game engine that is present here on the platform. The game engine is basically, I'll mention to you, is the P5 Play game engine. Is this basically this particular one? But of course you don't have to use it directly because it's already incorporated here. Being a platform with training wheels, we can use that game engine directly, and later on, once we learn the basis of game design and we know a little bit more JavaScript, we can just create bare bone or bare metal kind of programs. Anyway, coming back to the program, we see that the plane is moving on the screen, and it's just without having to do anything. Also notice we don't have to place any clear here like we did with the shapes. Clear is basically used for the drawing layer, so basically this layer in the middle where the shapes are located. Sprites don't require any clear. Once we basically go inside this object and change the properties, they'll smoothly move around on the screen and they'll not leave any trail behind. All right. So now we can put the same logic like we put with other kind of programs before. If p.x, perhaps if it's greater than 800. And 800, remember our canvas, it's 800 by 600. And until now we just put 800 all the time. Let me show you some other trick. We have a system variable width that is also 800. So if you're the type of person that doesn't like to encode constants in the code, well, one way is of course to define it yourself, but also remember that we have also this variable that it's 800, right? So if p.x is greater than the width of the screen, what we can do here, we can just make the plane jump at the beginning, or perhaps let's make it jump minus 100 pixels to the left. So it will not appear just there in the middle of the screen. So the plane is flying. It's a little bit slow. It's an old type plane that is leaving the screen and appears on the other side. And notice actually the plane is disappearing after half of it. It's out because the hotspot of the sprite is somewhere in the middle here. So when this hotspot is actually going outside of the screen, the plane is disappearing. So to compensate for that, we can basically put here if it's greater than plane width plus, I don't know, 50, or we can calculate exactly based on the sprite size. All right, so we have this nice cute plane that is actually flying on the screen. Let's define a constant here. Speed, perhaps we should have a speed that is 3. Well, let's have it here. And then plane is plus equal speed, much better. All right, so while this plane is running, and we already saw how to move sprites using the X and Y coordinate, perhaps we can now imagine all sorts of interactive games. We can use actually cursors to move the planes and not let them fly by themselves. Let me show you another way to in which basically we can move sprites. So this is basically with a for loop like that. But let me show you another way. You don't even need a for loop in some cases. The sprite itself has a property called velocity that is also an object, but the velocity object has another property, has two properties, X and Y. So just setting these properties, for instance, let's set this one to 3. Just setting these properties, we make the plane move. Basically, the game engine behind the scenes is moving the plane, but it left out of screen. So basically, all we had to do is to define the sprite and say this sprite has velocity this amount on horizontal. And the game engine, instead of displaying it in the same spot, with each frame it advances a little bit on the horizontal and displays it a new spot, so make it like it's moving. And this is sometimes interesting and useful because, for instance, we can have all sorts of objects or flying objects, and we don't want to write code for them to move. We can just put them on auto and they'll just on autopilot and they'll just move by themselves. Now, of course, we need to control where it's stopping. So, well, we can still put back this verification here. So we are not incrementing ourselves the X coordinate, but we are using the loop function to check when the plane reaches the end of the screen and make it jump to on the other side. All right. So see, it's very, very easy to actually move things on the screen. Let's move some things on vertical as well. What can we move? All right. Let's go here in the sprites. Let's pick this guy here. It's alone here on this page. So this is a coin, basically. I'm gonna run the program just like that to see how it looks a little bit. Yeah, it's perhaps it's a little bit too big. We can control that to the last parameter here, 0.5. Let's see. Yeah, it's a little bit smaller. Much better. So what we can do here, let's make this plane drop coins. So once it's flying inside here, what he can do, but perhaps should not drop coins at each pixel, but let's maybe check if p.x, we use the reminder with we divide by 100, and if the reminder is 0, so basically every 100 frames, that should be the this meaning, every 100 frames we're gonna create one of these sprites, right? Now if we create it like that, will remain stuck in the air. Let's see. Oops. No, actually we are creating in the same position in the middle of the screen. Let's create it at what coordinate? Well, first of all, maybe at p.x and p.y, exactly on the position of the plane. Let's create this this other. Yep, 1, 2. Yeah, they appear nicely. 3. So you have 3. And yeah, the plane just moved there. Right. But we said that we are doing this in order to also work with the velocity on the vertical. So let's take this in a variable. Let coin equals sprite, and we just have to set the coin.velocity.y equal 1. or you can set a random number, perhaps a random up to 2, so some will go a little bit faster than others. Let's run it. All right, so now our plane is dropping coins. Perhaps we can build a game to make a person go behind and collect the coins, and I don't know, we'll put some logic there. To win the game you have to collect this amount of coins. They drop kind of slow. Coins should drop much faster. So it's a number, maybe it's a random number between 2 and 5. Not between, yeah, much better. Also, if we are looking at the kind of coin, it starts on top of the plane. So there is a way to make the coin go behind the plane. But we're gonna see about that one in a second. Let's take this opportunity, let's take this mini program. Actually, let me share this with you. But what we want to do as a next step, let's make the plane move into the other direction, because that's another important properties when working with sprites. And not only in CodeGraph environment, but in all the other game engines. Knowing how to move sprites, how to kind of make them turn around or mirror them, making them, setting them velocities, those are very basic concepts when working with sprites. So let's see how to do that, but first let me save this one. So this is plane 1. I'm gonna save it. And I'm gonna put the program here on the chat if you want to open it on your side. So this is plane 1. And you know what? I'm gonna create a copy of it from this point on. I don't want to override this one. So my copy will be plane 2. So you have on the chat exactly this version. Now, what can we do basically to make the plane go back there? So we can check obviously if we are reaching the end of the screen here. And instead of making the plane jump here, we can change its direction. So why not define a variable here somewhere? Let me move this. Okay, let's define a variable dir for direction, which is 1 is going to the right when it's 1, and -1 probably is going into the other direction. So we can say if the plane goes outside of the screen to the right, we can make the direction, we can invert the direction. So the way we do that is like we did before, we multiply with -1. But the direction should also change if the plane goes back and goes to the left side of the screen. So here we can change, we can say, or if p.x is less than maybe -50, just to be similar to this one, we invert the direction. So, but this doesn't change anything. We just change a little bit we just change a variable. The plane will just not do anything. As a matter of fact, we'll just leave the screen right now. Oh yeah, I moved the variables and I broke the program. So now the plane will even leave the screen here because it's we are not even bringing it back. But what we can do here, we can say inside p.velocity dot x, right, equal the direction times speed. So if it's 1, it's basically speed. If it's -1, it's minus speed. So should be just fine. Let's see. Boom. Oh, now it's going backwards, but this will be kind of an interesting plane if we'll be like that in the real life. So what we need to do is to mirror the plane, make it turn around. So let's do that. The way we do that, it's similar. We are using a method this time of the plane. We didn't discuss too much about methods, but we encountered them several times when we discuss about strings and we discuss about arrays. Remember, also those strings and array objects had methods inside, such as to uppercase and so on and so forth. So the method that we are using here is mirror x. And there is a, like you can probably hint, there is a mirror y as well. So we want to mirror the sprite, just flip it around. If we are using 1, it's in the normal position. If we are using -1, it's basically flipped around. So we're gonna mirror it by direction, by dir, because 1 it's going that way and -1 is going backwards. So should be fine. So let's check. Come on, plane. All right. And now the plane is is just working fine. Yep. So this is the version 2 that basically it's similar to version 1 of the plane, but we just enhance it with a different logic here, and we use the mirror X method to make the plane go back and forth on the screen. I'm gonna share this one with you as well. Just if you are collecting these mini programs, if you plan to enhance them, you'll just find them on the chat. Plane 2. All right, the program is there on the chat. What can we do? What can we do? Well, these sprites, they are so wonderful. They have all sorts of interesting properties. You can even rotate them. For instance, look at the plane here. The plane is on horizontal, but look if we are putting p.rotation equal 30. Let's see. We just set one property, and notice the sprite just rotated like that, right? Now, it's not very useful in this particular case to be rotated, but there are probably cases when you want to rotate the sprite. It's similar to mirroring. You can also rotate it, and all it takes is just setting some properties on the sprite object, on the object returned by the sprite function here, right? And exactly like with the movement, you can also make the rotation be automatic, like the plane can move by itself, can rotate by itself. Again, this is not a very practical example, but let's try rotation speed. It's actually 1. Let's try something like that. Yeah. So the plane just rotates by putting a property, rotation speed. You can have a sprite just rotates around its axis, and you don't have to write any code. Actually, this is not very practical here, but perhaps when we are setting the coins, what about if we're gonna put some rotation speed to the coin? Rotation speed equal 1. Let's see. Yeah, so now the coins, as they move down, they also rotate. So perhaps let's put a bigger number here. Yeah. They were animated anyway, so they were looking like they were rotated on one axis, but right now we are rotating also the entire sprite around the other axis. So that's useful in certain kind of games. Now, these sprites that we are creating, we just create them and create them and create them, and basically even if they go outside of the screen, they are still there in the memory. So we need to see basically how we can destroy them. First of all, before destroying them, let me show you how we can hide them. Although hiding them is not something that that is probably what we are looking for. Let's create a new page here just to start fresh. All right, and let's basically bring a new sprite. Let's bring one of these other characters that we have here at our disposal. Perhaps this cute dino. Let's put it also, yeah, maybe the dino is in a jungle somewhere. And let's play with this dino and see, explore other properties of the sprites. Let's position it nicely somewhere. Oops, a little bit down. The dino is floating in the air. 400, 450, perhaps. Yeah, can be here. Or 430. It was fine there. Yeah, it's just fine. So we'll also take it in a variable. We can name this variable dino right now, and let's write a function mouse pressed. As you remember, this is basically also a special event. We don't have to call this function. Once we define this function, is automatically called in the moment we click with the mouse somewhere. So if we can say dino dot visible, this is basically the property of a sprite, and we can say false. And if we are running it, we see the dino, we click, the dino is no longer here, it's poof, it's become invisible. Look, since we're about the coding course here, let me show you how to toggle a Boolean variable. Basically, now it's true, then becomes false. If we click again, becomes true again, and so on and so forth. So the way we do that, we can say this thing here. Dino visible is not dino visible. We'll analyze the code in a second, but let's run it first. I'll click once, is visible, invisible. Click again, is visible. Look. Click, 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 click. Isn't this fun? So this is basically a property of the Boolean variables. When dino is visible, let's suppose dino is visible, not dino visible means false. So we are basically making it false. Now it's false, but not being visible is true. So we are making it true. So this is a way to toggle. So let's put here toggle the dot visible Boolean property. So see, it's very easy to write. Instead of this one, if we are not knowing this trick, you will have to say like this: if dino dot visible is false. We can write also code like that. Else dino dot visible is true. So that entire toggling is just so concise and takes just one line of code instead of all this loose code here. All right, we can have it commented here just just to know what it's doing here. I hope I write it correctly here because I didn't check it. But yeah, that's one way to basically hide sprites. You just set them a property and the game engine automatically takes care of their visibility here, right? So now we said that we are also interested in removing sprites, right? And to remove sprites, we can show to remove this one for now. So basically, instead of saying here dino visible, we can say dino dot remove, something like that. And if we run it, boom, we remove it and we cannot bring it back. The sprite is destroyed. So this is usually useful when, for instance, you have some ammo that is flying through the air, reaches the target, and then we make it, basically we remove it because we want to clear up that memory there. Yeah, so perhaps we can try to use this remove property a little bit in an example. Let's think what we can do here. Yeah, we can make, let's attempt here. Let me make this on dino visible. I'm gonna save this one, share it with you on the chat, although it's just one line of code, more or less. Dino visible here. All right. So so let's try to make these sprites to use the remove property in a perhaps a little bit more practical example. So we are starting a new one, and what we can do, we can rain with coins. I guess that's a simple example. Yeah, we can rain with coins. So let's create a function loop, and inside the function loop we can create those coin sprites. Let's create them at somehow random positions on the screen here. So we can let's say let coin equals sprite. We create this coin, can be size 1, and we can set the coin dot velocity dot y equal 1. So they'll start to, all right. There are lots of coins one on top of the other. Yeah, we should not start them at 400, but a random of width, which is any position basically on horizontal, and they should start at 0 there, and they should start, yeah, lots and lots of coins. Too many coins, as a matter of fact. But as you saw in this example, basically the game engine is taking pretty well the task of displaying many objects at the same time on the screen. But let's not make that many coins. What we can do, we can pick a random number, and if this random number is less than 0.1, this random number is basically returned between 0 and 1. So checking if it less than 0.1 means about in 10% of the cases. So in 10% of the cases, we want to create this particular coin. All right, we have a little bit fewer coins on the screen. Perhaps we should check even, you know, in fewer situations. We can also use that trick with frame count, and we divide it by, for instance, 100, and then take the remainder, and if it's 0, yeah, that works as well. So we create these coins, but these coins, there are lots of coins on the screen, and we want them to remove them once they basically go outside of the screen. All right, so in here what we can do, first of all, we can add them in an array to kind of be able to refer them, and then yeah, let's do that. Let coins, we can have an array here, and then here we say coins.push, and we put that coin in there in the array. And here we can also loop through the entire array for so for each frame we're creating some coins in certain situations, but all the time we are basically looping through the coins for each coins in the coins array. And we can check now the coin.y if it's bigger than 600, for instance, or we have a variable height similar to width, then we can say coin.remove. Let's check this one. All right. Now, we don't have a very easy way to verify if these are removed. There are obviously possibilities. But look, another easy way to remove them, to check if they are removed, let's change height here with 300 basically. We'll just check for a second if the coins are bigger than 300, the Y bigger than 300. Okay, and we see they disappear basically once they reach the middle of the screen. They don't go below that one. So we are assuming this code is working also fine. If we put here height, the coins are removed once they go after a certain threshold on the vertical. All right, so that's one way of removing them. Let me save this one. This is falling coins. And if you remember the big code that we wrote one of the other days when we created falling spiders, yeah, please refer to falling spiders. That's also an interesting one. But this one, it's even, the code is even smaller this time because we don't have to calculate all those coordinates. Engine is taking care of everything here. All right, so that's one way of basically removing the coins, but we have another possibility as well. For instance, we don't have to write this code at all. It's optional basically. What we can do, we don't even have to put it in an array. We don't have to track it if we don't want to. We can set here, we have a coin.life. We have a life property. And let's assign a number 100 to see how it behaves. And let's watch the coins. See, they disappear. This life 100, this life property, and it's assigned with a number, is basically specifying after how many frames the engine should automatically remove that particular object. So this is very, very useful for not important objects. Perhaps we are shooting with some kind of arrows, and we want them to just disappear after a certain number of frames, perhaps when they reaches outside of the screen. So we don't have to track them. We don't have to create an array and track them. So let's keep the first version here. And then I'm gonna put the version with live just to see how it's easy is that one as well. Falling coins version 1 here, save it. I'm gonna put it on the chat. Version 1, and then saving a copy. I'm creating a new version, version 2, and this time I'm using that live property. So just remove all this basically extra stuff. It's just a property on the coin.life equal, but not 100. We'll have to see it. Probably it's more than that. Yeah, we'll have to see it after how many frames we have to remove them. But that's all it takes. You just create the sprite and set a few properties on it, like velocity, and I put 500, and we should put 600. 500 is close to the bottom of the screen. But it's nice to see it anyway. So we are setting a few properties, and the engine is automatically taking care of this this aspect for us. See how easy it is? So let me share the second version as well. And let's put it here. Falling coins version 2 is very simple one. Is there. All right, so these coins are falling. Oops, where are my coins? All right. So yeah, perhaps they are. Let's make them a little bit smaller here. I don't like them being so big. 0.5. Yeah, just like that. Yeah, just like that. Let's collect them. Collecting coins. And how can we collect them? We can click on them. That's one way of doing it. Or let's collect them somehow else. Okay, let's say we have this guy here, the game guy. All right, this one. Yep. And let's make it move. Once we move the mouse, let's make it follow the mouse. That's also very easy to achieve. We'll have it outside here. Maybe this one is player P. I don't like the P variable too much, but we can live with P for now. We can remain with the P variable here. And inside the loop, what we can do, we can say p.x equal mouse x, and p.y is mouse y. All right. So if we are now running the program, we can see that the sprite is just following the mouse. All we have to do now is to basically check if we are colliding with these sprites, right? So how can we basically checking for collisions? That's also very, very important kind of concept when we are designing games. It's basically we have a very simple function here. So perhaps after we create coins, doesn't matter exactly where it is, we can say if p collide, and now we have to check if it collides with a particular coin, right? So we can bring back those that array, and that's one way of doing it. Because we need right now here to specify if it collides with a particular coin, but we have so many coins, we don't know exactly with which coin can we check to collide against it. So let's bring that back, that array. All right. And after we create the coin, we can push it here inside the array. All right. And now for each coin of coins, we can check if we collide with a particular coin. For now, let's print something on the screen to make sure that we are basically executing this particular piece of code. Where it's not working, we have an error here. Oops, yep. Semicolon, not exclamation mark. So let's run it. Yep, and indeed we have some collisions there that they happen really, really fast. So if it's colliding coin, what we can do is coin remove. We can call coin remove, for instance, here. Let's see. Boom, 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 boom. We're collecting these coins as we're bumping into them. Well, perhaps we can make them a little bit more animated. What we can do, instead of removing them immediately, we can change their velocity, like perhaps velocity.y it's -10. We make them fly up, and velocity on, and let's also change the velocity on x is 10, so they'll fly in a diagonal, hopefully. So let's run it. Let's leave the coins go a little bit down and hit on them. Yep. See, as we collect them, they just fly away coins. All right. So this is fine. We can also introduce a little bit of a sound here, perhaps. No, this is not appropriate. What can we find? Something interesting here. I don't know, we'll go with click for now, although it's not very... Well, we can spend some time and basically find a nice interesting sound, or we just go with this one for now. Click one. All right, so let's see how it sounds when we hit the coins. Oh, all right, we hit more than one at once. All right, so apparently it's working fine. Now, I want to show you something else regarding this array that we created here, coins. We also have a special construct where you can keep multiple objects of the same type, and that one is, we just have to write it like that, new group. It's a little bit of funky new syntax. We never encountered it until now, but it's just working like an array. There is a difference though. Once the coin is removed by the engine, it knows how to remove it also from this particular group. Otherwise, we have to remove it ourselves. So, well, this is a new syntax. As I mentioned, we'll study it in a future lesson. If you're not comfortable with it, you can just use an empty array for now, since that's what we use until now. All right, so as we can see, we can create even mini games. Perhaps we can have this guy here run on the ground rather than move it with the mouse and try to collect the coins that they are falling. Yeah, the sound is not chose correctly. Perhaps you should choose another sound. Perhaps you should do a much better job about this one. All right, so let's see. Well, perhaps we should move the guy into the next. Well, let's move it right now. We'll move it into the next example. Yeah, so we can keep score here. We can have a variable. Score is 0. And now I want to show you something. On this particular program and the one that we did today, we just use sprites, and we just totally abandoned the other things that we learned about now, how to draw circles and how to basically write text, but those are still there. Let's remember again this layout. The drawing layer is still there. We just have to write on it. So what we can do here in the loop, we can always use the commands that are the shape drawing commands, you know, circle, rectangle, fill, and the others to draw on that drawing layer. So let's use just text for now to display the score. And we can display it somewhere in the top left corner there. What we have to do, yeah, let's increase it each time we are collecting one, and let's get rid of the sound. Score plus plus. All right, the score is increasing, but we need to clear the screen or clear that particular drawing layer in order to see the text clearly. So we'll clear this one, and also let's use no stroke here. The text will appear nicer. Or and also fill of black. Let's write it with black. Something like that. All right. Yep. See, as we collect the coins. And there is a little bit of a problem here actually when we are hitting one coin. Yep, as we are hitting one coin, we are collecting more than 1 point. And that's because of the way this function works. We are registered collision several times. So what we can do is basically we can mark the coin as being collected, and so we can say, for instance, once we collected, we can say we can set a property on the coin itself, or you know what, we can check if it has the velocity less than if it has a positive velocity, right? So if we try to collide, and basically if coin velocity dot y is greater than 0, which means it's basically falling. Yep, we just collected 1 point. Yeah, we just collect 1 point. Then we basically run this logic, right? Because immediately after run this logic, y become negative, velocity becomes negative. So will not register this again. And now let's pick another nice sound, because still makes sense to have a nice sound for this one. Let's see if we can find a nice sound. Yeah, yeah, this one. Let's see if this one, I like this one. Perhaps we should move it outside of the logic here. Let's see. No. Yeah, first time has sometimes a glitch. Yep. And we can now happily collect coins. Let's try. As a matter of fact, we can collect all the coins there. Perhaps we should not make the character move with the mouse, but move it with the keyboard. That will make the game more engaging. Nevertheless, let me share this one with you. And I hope that you'll extend it and you'll implement a nice game, turn it in a nice game, or at least come up with an idea for a nice game and write it there in the chat, and we can try to build the game together. Alright, this is collecting coins. Alright, the program is on the chat. So let's start with a new page and see what else what else we can do with these codes. And yeah, one thing, when I mentioned that we can combine the layers, the drawing layer and the sprites layer, and you saw also on this image there are two layers of sprites. The reasons for having two layers of sprites is because we can have some sprites behind the drawing layers and some sprites above the drawing layers. So let's pick, basically, let's do this as an example. Let's pick two sprites, 1 and 2. All right. So we have two sprites. Perhaps this one is on 100 and this one it's 700, or too much. Oops, not the other way around. This 100 and this 700. Yeah, they're fine. And now let's implement quickly a for loop, a loop event, function loop, and inside the loop we're gonna just use the drawing layer to basically draw a filled circle at the mouse X and mouse Y coordinate. So the way we're gonna do that, we'll clear the drawing layer and then basically we'll fill with a particular color. I don't know, can be green, and then we can have a circle at mouse X, mouse Y, and radius 30. Make it a little bit bigger. Let's see. Right now, if I'm moving this one, notice that the circle goes behind the sprites, which means that these two sprites are drawn in the layer that is above the drawing layer, and to draw them in the layer behind we have to set the depth property. So let's say this is sprite 1 or player 1, this is player 2. I'm overusing the p variable today, and I can put here depth equal -1, and all right, depth -1, depth I had the spelling there. See, now the circle goes behind the second sprite, but it's above this sprite. And it's exactly like it says here. Sprites with depth less or equal than 0 are drawn basically behind the drawing layer, and sprites with depth bigger than 0, they are drawn in the other layer. And also what I want to mention here, that is this depth property, you can use it not only for the drawing layer, but also to control how other sprites are drawn on top of each other. So let's also pick another sprite from here, perhaps, just to illustrate that one. Let's choose, yeah, let's choose the coin again. We're just gonna overuse these ones. Let coin. And also inside here, perhaps we can also move the coin at mouse X and coin Y at mouse Y. Now, by default, the coin has, and so also the circle there. Perhaps we can just for a second disable those lines. Now the coin is basically above both of this one, but notice what we're gonna do. If we can say coin.depth equal -2, now the coin should just go behind both of these sprites. And this is very important when we want to control what sprite goes in front of the other sprite. This is something that you can do using the depth property. And basically, if we come back now, let's save also this one, depth, and save it. And we can also activate these lines. It will be a little bit busy, but nevertheless, yeah. Now also that coin is behind that circle, and both are behind, and now one is behind and one above. I can share this example with you. They are not big examples like before, so today is a very, very simple lesson from coding point of view, but at least it offers you an overview of the sprites. So this one is, this is the depth property. I'm sharing that there. And if you are coming back to the example that we built with the plane, the first one, perhaps plane 2, when we are running, see that the coins are actually originating somewhere on top of the plane. If we want them to be behind the plane, we can just say coin.depth, and -1 should do it probably, because plane it's probably at depth 0. Yep. And now the coin starts from behind the plane and look a little bit more natural when they are falling. Even they look like they remain behind once the plane is moving forward, which is cool, I guess. All right, let's save this one, and perhaps we can extend it a little bit. Why not actually make somebody collect the coins that falls from the plane? So we can do that in a second. We'll come back to this one. But before doing this one, we'll do like a final exercise. Perhaps before showing this one, I want to show you a particular aspect of the sprites. Something that you can probably notice, and we also talked in the previous lesson. If you hover your mouse, some sprites show a small snippet of code, and they show you basically how to change the animation. And we saw that we can select a particular animation once we draw a sprite into the code. So let's draw perhaps this very first one. And look at the animations there. It says P show idle, jump, run, slide, shoot, and so on and so forth. So we can pick run. Let's pick run and idle. Once we drag and drop it, the editor places is here idle. So basically the sprite as is drawn in this default position is in the idle state. We can put here running if we want. Wasn't running, was called something else. Oh, just run. All right, just run. If we are running it now, we'll see the sprite is drawn in the running state. So these sprites have multiple states inside. Most of this one, just hover your mouse over them and you're gonna see they have different states, and that snippet shows you how to change the state. So here is how to change the state in the moment you bring a sprite into the program, but let's also change it dynamically at runtime, right? So let's bring it back to the initial position. This is again, the sprite is called P from player. Is not a good name anyway. So let's handle now function key pressed, just like that. And let's say if we press the key 1, we want to show first animation. If you press key 2, you show the second animation. And this will also give us the opportunity to practice a little bit this key pressed event. All right. So we have also a special variable called key. We discussed a little bit about it. It just returns it that the last key pressed. So we're gonna check if key is 1. Perhaps we should show. We can say just p show. We use method show basically to change the state of a sprite, and we can put here run. Let's see it. I'm running it. Press 1. Yes, and it changes. It's running. Run. Yeah, let's put a background. It's much nicer when we have some cool background behind rather than this boring white. Let's bring this background here. Mist forest. Let's see how it looked like. Yeah, almost good, almost good. The sprite maybe should be at 320, and we should yeah, so if we are pressing 1, is running. Oh, let's make, if we press space, we bring it back to the idle state. So what we can say here, else if key equal space p show idle, run it, 1 running, space stop. All right, so let's see the other states and cycle quickly through them. So has also a jump, slide, shoot. Let's test just a few of them. Jump, slide, shoot, not all of them. So what we're gonna do, we're gonna use an else if structure here. There is also another way in JavaScript to do this one, but with what we learned, this is the perfect way right now. So we're gonna use an else if structure, jump, and yeah, just slide. Let's say slide. That's it. So we don't do too many. Let's run it. 1 is running, space coming back. 2, this is jumping state. Perhaps if we make this character jump, we can change the state to reflect that it's jumping. And 3, it's sliding. Yep. Okay. Okay. So this gives us some ideas about some games. Let's perhaps even this particular character, we should pick it and make it a little bit move, right? With some commands. So let's see, actually, instead of this one, let's name this one show change animation. Change animation. We're gonna share this on the chat. Just like that. And now let's try to actually put this one into a little bit more realistic kind of program, and control with the left keyboard to make the character go to the left, and we should basically change the position, and then go to the right. When we press the other key, eventually mirror it to go into the other direction, and perhaps we're gonna implement also a little bit of a jumping, depending on how we stay with the time. So let's start again, just to not have any other code written there. Let's bring a nice background here. That was nice. Well, we can pick Pink Mountain this time. Or let's pick something else, something nicer if we find. No. No. Miss Forest was nice. Yeah, we're gonna pick Road. It's fine. Doesn't matter at the end of the day. So, and let's pick here, let's bring into a program a character. Which one we should pick? We can bring one of these characters, or I'm thinking to pick perhaps a dino. What states has walk, run, jump? Yeah, good enough. Walk, run, jump. Let's see how it looks. All right. All right. The dino should be at 500 here on the vertical. Oops, too much. 450. A little bit up. 430. Yeah, just there. So let's have it in a variable dino, and let's see how we can control this one. So we're gonna create a function loop, and inside here we want to check if we are pressing the left arrow and right arrow, and if we are forgetting the commands, we can go here. Let's go under user input, and yeah, key is down. This is what we are looking. So we want to check if his key is down, left arrow, and then if key is down, right arrow. But let's check with left arrow first. All right. So this is what we want to do, basically, to accomplish. And once we press the key down, we move with the dino to the left. So if the key is down, you know what? Let's put also if we press the right arrow. So also else, if it's right arrow. So we have just two keys that we use, left arrow and right arrow. So what we are doing if we are pressing the left arrow, dino, we can say .x minus equal with a certain number of pixels, we move it to the right. Whatever number of pixels, 8 pixels, 5 pixels, and if we are pressing right, it's just going to the right. Let's see it. Yep, working well, but it's kind of sliding here. This sliding effect is not kind of what we want to do. And also, when we are pressing to the left, we want to mirror the sprite. Let's mirror it. That's pretty easy to do it. So we can say dino.mirror x of -1. Yeah, and if we press the other one, we mirror 1. Let's see at least if the mirroring is working. Yep. We still have a sliding effect. Whee! And we are back. Yeah, let's change that one. If we are looking at the dyno, it says that as an walk or run state. We can try them both. So basically, when we press the key there, we want to change the state. So let's press here. Let's change the state. Dyno show. Let's try walk. If it's walking too slowly, we change to run. Let's see how it's looking. Oops. It's quite okay. I wonder though how. Oops, but it stays on the place. Let's see how run is looking. It seems that it's going somewhere really fast, but I think walk is fine for now. And basically this is how the game engine is drawing this. But there is one thing, we notice that the dyno remains in this state, which we don't like. So what we can do, of course we can do many things, but one of the simplest way we can do is basically to go in the beginning here and try to reset the state always to idle. I think idle was, yeah, idle is the default state. And if we are pressing the key goes to this state as long as we keep the key down, and once we release the key should basically be reset to idle. So should be a more natural movement. Let's see. Yep. So yeah, we are getting there. We can already imagine in creating some of these interesting games. And perhaps let's make right now. Can we bring that plane with the coins here and make it rain, and the dyno will try to collect the coins? I think we can do that. So we can bring the plane, or yeah, let's bring the plane. Let's bring the plane. So what was this one? Oh, we didn't save it. Dyno. This is dyno. We'll save it. Let's bring back the plane. Where was the plane? Plane 2. Yeah, this is the one. Actually, let's open this one in a separate. We'll keep this code in a separate code page. We shouldn't close this one. Let's go back to dyno and use a little bit of code from here. So we'll have the plane that is flying. We're gonna take this code. Let's bring it here. These are applicable to the plane. Let's name this one plane. Plane. All right, so we have the dyno. Let's bring the constants a little bit up. We have the dyno, we have the plane, we set the velocity of the plane, and inside here for the plane we can have this implementation. So yeah, we can have it. We can have it inside here, or we can extract it in a function. Function update plane. And of course we should refactor also the other one as well. So let's put this one update plane. Oh, but here we have the variable plane this time. So plane, and coin, that's fine. Let's make the coin simple. We don't need this one. Yeah. Let's see if it's working. P is not defined. All right, we have a P variable. Yep, this one. So starts plane. All right. All right, seems to work together. Let's move also the other code, not to have it inside here. We can have function update dyno, and the other logic we can extract it in a separate function, just to have a little bit separated. And here inside the loop, we just updated either the dyno or the plane. Or actually, we update them both, right? So we update them both, and the plane just leaves these coins behind it as it goes. And we can also move the dyno with the keys, see? Perhaps we should make it a little bit smaller, because it's kind of large. We collect coins. It's a Godzilla. So the way we're gonna collect the coins is basically we're gonna check each time the coin falls, we can put it in one of those arrays that we put before. Also, we can give a life to the coin. Life equal 100. Not 100, 200. Yeah, 200. Yep, 200 should be enough. Let's check if basically the dyno is hitting one of the coin. So, all right, let's have an array. We'll do the same implementation as we did before, coins. And we can have it an array, or we can say we write this construct here, new group. Just like that, with new and group separated, and group with parentheses. It looks like a function invocation, but with a new keyword in front. It's a funky syntax. We can just leave it like that for now, which in essence, basically this is, we are instantiating an object using a different syntax that we then didn't encounter it until now. But we can leave this one, or we can put array if we are not comfortable with this one. Array should work just fine. So once we create the coins, let's add them to that group, coins.add coin. I think this was the syntax, if I not forgot. Yeah, it's not giving any error. Probably it's working, I hope. So right now, let's also go and create here a function, check for coins, check coin collision, something like that. It's a funky name. Function check coin collision, and what we can do inside is what we did before. So we can say if dyno dot collide. Now we can also, there's a special feature here. We can check if we collide the entire basically coins collection, but we're gonna take them separately because this requires a little bit more advanced concepts, which we didn't discuss until now. So let's loop through all the coins. For let coin of coins, if dyno collide with any of the coins in the collection here. All right, what we should do, first of all, let's make the coin.velocity.y equal -10, and also let's make the velocity.x equal 10. Let's make it fly really quickly upwards. Let's see if it's whoops, yep. Now notice that sometimes the coin is basically flying even if it's not touching the dyno directly. It's a little bit in front of it, and that's because of the bounding box that it's around the sprite. There is a way to see that one, to visualize that one. So I think it's dyno.debug, if I'm not mistaken. Yep. So see, this particular dyno has a pretty wide bounding box. Actually, that's where the computer calculates collisions, and we don't like it this big. We can make it a little bit smaller. I don't recall the syntax, but we can Google it. It's P5 play bounding box. Bounding box. Okay. So let's see. Get bounding box. There is a get bounding box. There is a or set collider. Yeah, I think set collider should do it. or bounding box, one of these methods here. Anyway, it's not important right now, but the main point here is that we can change these bounding boxes. It's not necessarily bad, only in the front here it's a little bit too big, and it looks like it's hitting the coin even if basically it's not touching the dino. So we can change that one. Again, is bounding box something that we have to change. We can look there on the if we have time, or I can update this one post streaming. All right, so it's collecting the coin. Let's we can make it go even faster, and let's have a score here. Let's have a variable score. Let's place it here. Score is 0 initially. Here, let's say display stats, display statistics. We can have a function here that will display the statistics. We'll draw it on the drawing layer, so we have to clear each time. We say no stroke. We fill it with black here. That's how we like to display the score. It's not the only way, just draw it as however you prefer. And we put a text saying score plus score, comma, and we put it somewhere in the left corner of the screen. Right, so come on, let's, okay, we didn't increase the score. So when we are hitting here, yes, we change the velocity, and then we score plus plus. All right, and we have the same problem that collision happens multiple times until the sprite gets the chance to move away. So let's do the same verification here, and we can put a flag saying that okay, the coin is collected. That's probably more cleaner, but anyway, we can check for against this variable since we have it here, and if its velocity is greater than 0, then only do these things. So that's okay, so we collect just once. All right. And we can make also, if the coin goes outside of the screen and we are not collecting it, we can basically perhaps, I don't know, lose the game if we miss 5 coins or something like that. We can put our own rules at this point here. All right, so let's see. I'm searching again that thing, bounding box. I don't recall the bounding, is this one for sure. All right, we can find it out other time. But look, let's change for a second just the dino. Instead of the dino, let's pick night. Night should do it. We just change it here. We don't change the variable. Let's see. All right. This one has at least a much nicer bounding box. It's kind of tighter to him. So if we make it a little bit smaller, should also the bounding box should be smaller. So see, you can customize this game or reskin it the way you prefer. You can change the background, you can change that plane that flies, you can maybe make another sprite fly there, you can change the player, you can create your own version and then share it with friends and have fun and make them play the game. Perhaps this is an interesting idea. Make this a mini game, and once they collect 10 coins, then just display a big message there saying congratulations, happy birthday. Okay, maybe let me show you again how to do that one, how to display happy birthday if they collect 10 coins, or the number of coins that perhaps their age is. So here we can increase the score, and we can say if score equal to 10. Well, at this point we can show scene congrats. So let's create a new scene here, congrats, and on this scene perhaps we should put some nice nice background. This one should be okay, and let's write with big bold font in the middle of the screen, text size 80, and perhaps we should say text happy birthday, and we write it at 300 and 300. I don't know how it looks like. Let's not use a stroke, but instead we should fill it with red, something like that. Let's see, and let's collect 10 coins really quickly. 1, 2, 3, 4, 5, 6. Should have put a smaller number. 7, 8, 9, 10. Happy birthday. We should make the text not at 300, at 100 here. Should be a little bit to the left. So should be fine. And let's make a nice music to it. What music can we have? Fun. Yeah, this is fine. And then when we change the scene, we can also change the music if we want. We can make it okay, let's make this one. Alright, so let's play again the game. And now these musics, they have also, you can change the volume here. You can place a 0.3 perhaps, not be that loud, and this one can be louder. Alright, let's run the code right now and play our game. Before that, look, this is the entire game. It's not too big, just few lines of code, and many are not necessary. We just added them as enhancements. Let's run it and play it. Oh, let's remove that debug true. We don't want to see the bounding box. Oops, we collected it. Alright, I hope you like it, and you can create this kind of personalized games for your friends and send them. So let me share this one with you. Dino. And it's on the chat there. I hope you like it, as I said. I find it pretty fun. It's so easy to create this kind of mini games when you have the right tools, and with a little bit of a JavaScript for logic, for glue logic, you can basically manipulate all these interesting sprites and create really interesting things on the platform here. Let me show you one more thing before we wrap up the lesson, and that's basically another important concept into this kind of games is how to achieve the jumping. And we could have made the dino jump, that's one option, or we can pick another sprite. So let's pick another sprite for now. Perhaps we should pick a dog or a cat. A cat? Yeah, let's see if the cat has the jumping state. Yeah, has walk, run, fall. Oh, has jump. Yeah, let's pick a cat. I never use a cat in a video game. It's kind of cute though. Let's pick a background, appropriate background for a cat. The cat. This one? It's an autumn? Let's see. Yeah, it's okay. Okay, alright, we'll use this one, but again, feel free to reskin the game and pick your own background images and so on and so forth. Music, graphics, I'm sure you'll do a much better job than me. Alright, so this is the cat, by just two lines of code, a full program with 2 lines of code, and the cat is even moving, it's in the idle state. All this with the power of the game engine, so nothing here. So, we're gonna do the same, we're gonna press the key to move left, the right key to move right, and space perhaps to jump. And you know what? Instead of making actually the cat move on the screen, we're gonna just keep the cat in the same position. And in this, there are certain kinds of games where actually the player sits in the middle of the screen and the other objects or the scenery is actually moving. So I'm gonna show you how to do that as well. So let's implement here really quickly the loop function. Function loop. Let's name this one cat, just like that. So we are inside the loop function here, and we're gonna just go a little bit quicker, but we'll basically implement the same logic as before. All the time we try to make the cat in the idle state, just to, and then once we press some key, switch the state. So if key is down, I think this was the function, left arrow, So if we press the key down left like that, okay, else if keys is down right arrow, we can do this thing here. What we can do, yeah, the space. Let's check also for space. And I told you last time I don't recall having a constant for that, but the key code for space is 32, which we can check with like we did last time. All right, else if 32, basically we want the cat to jump, to jump, right? So okay, maybe instead of putting the program in all the place here, we should say run of -1. We want to run to the left. If we press the right arrow, run to the right, 1, this direction. And if it's this one, we want to jump. Okay, maybe it's better this way to structure the program like this one. And now let's define these two functions. Function run, and we'll basically receive the direction as an argument. And then we have function jump, that we don't receive any argument. So inside the run, we have to change the direction of the cat. Yeah, with the direction, basically to change the orientation with the mirror, and then also change the animation. And let's check really quickly here. The cat has, yes, animation for running is run. So we can say cat.show, just like that, run, and then cat.mirror x of direction, because we are sending either -1 or 1 from here. Let's see. Pressing the left arrow runs to the left, pressing right arrow runs to the right. And as I mentioned, we are not moving. In this one, we try not to move the cat. We keep it in the same place, and eventually we can have other objects coming towards the cat if we'll do the objects, but we can extend the game maybe other time. All right, so now let's see if we press the space is not doing anything. So there are so many ways to implement the jump in this kind of games. One way to do it is basically we can just cat.y, we can move it 100 pixels like that, and the cat jump there, and then we can have it falling down. Jumps but doesn't fall down, so let's have a fall method. So else if it's not jumping, the cat is always falling. The gravity is acting on the cat, so the cat is always falling. So we should have a fall function, right? So if it's falling, maybe, yeah, maybe we should use with the velocity this time to fall. Cat.velocity .y, the y velocity, we add 1 all the time to the velocity, so should come really quickly down. Let's see. Oops. All right, so I get the chance to press space, the cat jumps, but then falls forever. And I cannot bring the cat back. The cat is too far down, so I don't have to fall it unless basically you can check if the position is, yeah, we can check against this 450 position here, right? So if cat.y is greater than 450, the velocity, we should reset it and basically become 0. Right, and eventually also the cat, we should bring it at 450, just in case went a little bit down. I'm not sure if it, yeah, we should also go a little bit down, so if it's less, greater or equal, then yep. All right, two problems. First of all, is jumping too fast, but that's not that a big of a problem, to say like that. It's okay, but not have a big problem. It's landing much smoother than it's jumping, actually, because it's normal, because we just jump 100 pixels just like that to through thin air. We are not gradually going to that direction. We can fix that one. Perhaps we can make the velocity go up a little bit instead of that. Let's do that. And the second problem is that we can jump in mid-air. So if we press several times space, it just jump, which is in some games that desirable, but perhaps not in our game. So instead of doing this one here, we can also say cat.velocity.y and basically we assign a -25. So the engine should move it 25 pixels up. Yeah, see, it's not going there directly. It's jumping smoothly. Now we can obviously tune these numbers and make them, you know, more appropriate to how we want, rather than have them this 25 and these numbers that I put. But let's take care, more importantly, of the other aspect here. Let's take care of that jumping in mid-air. So look what I'm gonna do here. If he's jumping, I want to set the cat or the sprite in a certain state, saying, okay, is jumping state. And let's say when it's falling state, and when it's standing state. And the cat can only jump if it's standing. If it's not standing at that moment, will not make it jump. So let's set these states, and we're gonna use also a special interesting property of objects. We can just create new properties on an existing object. So by just saying cat.state, state doesn't exist. Cat object doesn't have the property state. But with any object, if we are assigning a property that doesn't exist, the JavaScript engine is creating that one, even with the objects that we worked in the other lessons with them. So anyway, we use this ability of JavaScript just to basically have this string here injected in the cat, jumping. So we are setting the state to jumping, right? And well, when it's falling here, we can also, so it's falling, right? So if we can say if cat.velocity.y, if this one is basically greater than 0, we can also have the cat.state is falling. I'm not sure if we need the falling state, probably just standing. But anyway, so when it's standing, well, in this time is standing. When it's trying to go below and we reset the velocity to 0, this is actually the cat.state is standing, right? So right now the cat is just standing, right? So should be fine. We can still double jump in midair. So in order not to double jump in midair, let's go there where we are checking, yeah, here. And instead of basically checking only if we press the space, we check if we press the space and cat.state equals standing. Let's say if this is the right thing. Yep. Now I cannot double jump. So I can jump only once. There is still a little bit of a problem though. Notice when we are running, we are changing the animation appropriately. Let's change also animation when we are basically jumping or when we are falling. I'm not sure which animation to change. Actually, depending on what the capabilities of the sprite. Yeah, it doesn't have a falling, but has a jump. Yeah, jump. We can change it in many places, that one, or we can go here when it's falling. Yeah, I think when it's falling we can change it here really quickly. We introduce all the other states. We can say if cat.state different than standing, we can make cat show and this jump. Let's see. If the cat is in any other state than standing, should display as jumping. All right, and we can jump. And basically at this point we can envision a game that we can create. We are running a little bit late. Let's see. Let's create really quickly, but super quick, a series of coins. let's see if we can achieve this task, otherwise we'll continue in another lesson. So let's say new group. Again, this is equivalent to an empty array, but by only one observation. Use new group only when working with sprites. In all other kind of programs, don't replace arrays with this construct. This is just applicable for sprites, all right? It's basically an array that the sprite engine is managing in a certain way to control the sprites. It's much better to use this one than an empty array. So it's basically an empty array, but you initialize it this way. So let's have a function here, create coins, and let's see that yeah, the coin sprite is this one here, and let's create, I don't know, n coins. So we'll say for let, all right, let's zoom up a little bit. Okay, for let I equals 0, I less than n, I plus plus, and we can have a coin. How many coordinates should be? Let's build them off screen. So basically from the edge of the screen, so from 800 to perhaps 1600. So the random between 800 and 1600. So this one won't be visible, and here random 600. So we'll build them randomly on vertical, and 0.5 coins the size, right? And coins.add. Oh, one difference: if we are adding to the coins new group collection, we say coins add instead of coins.push when we are adding to an array. So a little bit of a difference, but other than that, they're just normal, like normal arrays. It's just a collection. It's a little bit of a specialized array. So we are adding that coin over there, and it sits, right? So let's create the coins here. We invoke create coins, perhaps 50 coins. 50? Too many? Perhaps 30. Just start with a lower number. All right. So nothing happens here. But what we can do. Why is not happening? Because we are we are drawing them off screen. So let's see them if we are drawing them inside the screen. Yeah, we see coins here, right? So let's draw them outside of the screen. So what we can do here, we can make also the entire coin fabric for all the coins advance to the left once we basically press a certain key. So when we press the left key, for instance, we make the key go this way or the other way. So we can have here update coins, also -1, similar to run, and here update coins with 1. Let's have it this one perhaps at the end. Function update coins. This is the direction that we are receiving, and what we want to do here is basically to iterate on all the coins. Let coin of coins, and now we can say coin.x. We are adding plus direction, right? Or plus equal direction. Do we have a speed here? Let's see. How fast is this guy moving? Yeah, we don't have any speed. We can introduce a speed. Anyway, let's move to the right. Oops, they don't move nowhere. Let's bring the coin just for initially to have them here, and let's see how they look. So if we move, yeah. If we go to the right, actually the coin should come towards us. So the direction is inversed here. So update coins here, it's with 1, and here it's with -1, right? So yeah, yep. And now let's make the coins actually how they were originally off screen. So from 800, and we're gonna run the program. So if we run it to the right, we see the coins. If we run back, we go away from the coins. So what we can do right now is basically check for collisions, and also we can jump and collect all these coins, perhaps have fewer coins, not we created 30 coins, so if we create 30 coins, perhaps we should be 800 times 3, more space here, not to cram all in the same space. Yeah, even this, they are crowded. And we can also have a speed, because everything is moving so slowly. So let's have a constant here somewhere, const speed, perhaps it's 8 or 3 or some of these numbers. So when it's running, now it's fine, this is fine. Just when we move the speed here, the coins, we multiply by speed. Just the decor is moving with a speed. So let's see. All right. All right, we move them, and now we can check if basically we update, and we can check if cat dot collide with a certain coin. Well, we do we can do like we did with the others. We can remove the coin immediately, or we can check basically yep, yeah, we can remove the coins, basically means we collected the coins, or we can make them fly away. Make them fly away. I like that effect. Coin.velocity.y equal -10, or whatever number. Coin.velocity on x equal 10. And also, because we know will happen twice, let's also put here and coin.velocity.y greater than 0. Only then we do this thing, right? And also we can have a small sound like we had that time. Let's pick the same one. Yep, this one sounds really nice. So we do this one, and of course we can have score, and we can have, you know, we can, like in any other games. Let's see. Oops. That's not good. What happened? Where is our cat? Let's see what happened here. All right, let's run it again. Oops. The coins are actually pushing the cat outside of the screen. Actually, this is a behavior of the collision. If two objects are colliding, one is pushing. So if one is not removed, this is what's gonna happen. So let's see if why this coin didn't leave the screen. Velocity, I didn't spell it correctly. Let's remove it. Let's remove it. Let's see what's happening. Oops. No. If cat collide. But we just saw this 1 second before. Let's remove this one a little bit. Yeah. We can remove them. And coin.velocity.y is greater than 0, which is okay. The coin has not been put in motion yet. Huh. I wonder why this is not working properly here. We can debug it, no worries. Let's just set it without verifying it there. Now it's fine. For whatever reason that is not working there, but we can figure out why it's not working properly here. All right, let's see. You know what? This can remain like an exercise. We are running late here with our game. Let me play it a little bit, and I'm gonna share it with you. I didn't save it. I realized I didn't save it. So I wrote all this code and didn't save it. So this is basically jumping cat. This is Jumping Cat, and we're gonna share it on the chat. All right, so I hope that you liked today's presentation. It was not all about JavaScript, but about elements of the game development and sprites. However, if you want to basically build games using JavaScript, this is a good start. And the platform here is giving you the all the elements to get started with this one. You can evolve into more mature platform as you learn more about JavaScript. Of course, the JavaScript knowledge that you learn, you can use it beyond game development. You can use it for other kind of activities such as web development, perhaps. You can write all sorts of cool applications using these kind of techniques. So I hope you had fun. We'll end here the stream. We still have an error in this program, but of course you can figure out after time, or just if you debug it yourself, leave a comment in the chat there. And with this, I'm saying you happy coding. Thank you for watching, and see you next time.